Alright, so today we'll be talking about exponential functions. Now, these functions are different from linear functions in that they don't go in a straight line, obviously, but they also come in the form of a times b to the x power, where a does not equal 0, b is greater than 0, b does not equal 1, and x is an integer. Okay, and typically a graph looks like this. Its usual y-intercept is about 1, so we're going to go to Desmos real fast. I'm going to show you how it actually looks like on Desmos. Alright, so here's the exponential function right here. Okay, a times, now the plus h, the plus k, you'll learn later on and stuff. We're just going to focus on the a and the b right now. Now the a is actually the initial value, okay, so if I zoom out a little bit, you can see it a little bit better. The bigger I make a, the larger it gets faster, which makes sense because I'm multiplying by a larger number. But if you also notice that the number of whatever the y-intercept is will actually be a. So if I want to tell where my graph is ever going to cross the y-axis, I just look at what the a number is, which is the number in front. Okay, now if it's negative, obviously it's going to be going down and it's going to be decreasing in value. Okay, so let's make this back to 1. Okay. All right, now b. Now you probably were wondering, well, what happens if it is 1? Well, if it is 1, you got a straight line, because guess what? 1 to any power is 1, and it's just a straight line at y equals 1, or y equals a. Okay? All right, so that's why we always have it at 2 or something above. Okay? And as you can see, as I increase and decrease, it just makes sense. All right, now if I try to make it negative, it's not going to happen, so I have to do a little trick. So what I'm going to do is I'm going to increase the window to steps of, let's say, 0.1. Okay. All right, now as I decrease, and as you can see, it gets more there. As I go below 1 but greater than 0, this will actually start to resemble something a little bit different. It will be what is called a exponentially decreasing problem. Right here it's exponentially increasing. Over here is exponentially decreasing, okay? But if I try to go negative, it doesn't happen. If I try to go 0, it doesn't happen, okay? Because just of all the work that we've just been working with, okay? All right, so please understand, when your b is going to be less than 1 but greater than 0, you're going to be dealing with an exponential decreasing type of problem. Okay, so let's change this back to 2. Alright, but this is what it typically looks like, and this would be 2 to the x power. This is what the actual thing would look like. Okay, now if you were looking at a table and trying to write a function from it, you would look at the values and see what they're increasing by. With linear functions, we are increasing by a positive or negative plus or minus. We are always adding or subtracting. With exponential functions, you are always multiplying. So for example, this is multiplied by 2, this is multiplied by 2, we multiply by 2 to get here, we multiply by 2, we multiply by 2. I mean, you just keep multiplying by 2. Let's say that much. Okay, so you just keep multiplying by 2. Even though, all right, and so on this one, you would be increasing on the x by plus 1s and stuff, and that doesn't matter as much. Okay, all right, but once again, we're going to use the 0 as our prime spot to know what a is going to be, except this one is going to be a. So right over here, 1 is going to be a. So in our form of y equals a times b to the x, it's going to be pretty simple. We're not going to be putting anything in for x, okay, but this 1 right here is going to go into place of the a, and this 2 right here is going to go into place of the b. Okay, so that's pretty simple. So this is going to be y equals 1 times 2 to the x. Okay, or you can just simplify that to y equals 2 to the x power. And this is as simple as that, and you can actually work it out that way. Okay, and because Desmos is so powerful, you can actually plug in your numbers and do your exponents and just work your way through there. Okay. Alright, but that's it for all of your knowledge that you need to know right now for exponential functions. Please feel free to use Desmos quite a bit and have a great time. Oh, let me show you something about Desmos too. My bad. One sec. Okay, if you need to find out a certain value what y is going to be, you can drag the points on here and actually find what the value is going to be. So for example, when the value of x is 3, the actual y value is going to be 8. Okay, when the value of x is 4, let me zoom out a little bit so you can see it. It's going to be 16. Okay, when the x value is 5, it might be a little bit bigger. There we go. Boom. It's going to be 32. Now, what you could do is you could basically set up your problem and set up the two parts equal to each other, just like we solved for before. So like, for example, if I wanted to find out what x was going to be, if I knew that my final value was 3200 and I plug that in for y, obviously, and it equals 3 to the x, okay, and I wanted to find out what x was going to be, okay, what I would do is I would graph the two equations. I would graph y equals 3 to the x, and I would graph y equals 3200, and I would see where their intersection was. And there you go. And that's how you find the value of x when you're looking for a certain total value. Okay? And that's it for exponential functions. I'll talk to you guys later. Bye.